Okay, so look at number 6. Which scatter plot demonstrates a nonlinear relationship between x and y? Remember, nonlinear just means you could not draw a line through all of the points. Or if you were to draw a line, most of the points can fall along the line. So if you can't do that, then it's nonlinear. So look at A. If I draw a line through all those points, they all kind of fall along that same line. So that would be linear, so this one's out. B, same thing. I could draw a line. That's not very straight, but all the points kind of fall along the same line. So that's linear, so that's out. C, holy cow. Could we draw a line through any of this? Not a straight one. There's not really a great trend. And D, I can. It's linear. There's a line. So C. On number 7, which scatter plot demonstrates a linear relationship between x and y? Same thing. If it's a linear, can I draw, holy cow, a straight line through it? That's what I'm looking for. This one I was looking for nonlinear, this one I'm looking for linear. Well, right off the bat, I can draw a pretty straight line through that and all the points sort of fall along the same line. Let's check the other ones just to make sure. B, not so much. You could make something that would go through all of these points, but not a straight line, okay? So that's nonlinear. C, the points are kind of everywhere. There's really no trend, there's no association. Couldn't really draw a straight line where all the points would fall along the same line, so C doesn't work. D, so this one's kind of funky. D, since it's so scattered out, there's not really a full trend. So I would say nonlinear, so this one wouldn't work either. Number 8, alligators. Alligator sizes are displayed in the graph below. Alligator size, our Y is our centimeters, and our X is our length. Oh, okay, so this is your width in centimeters, and our X is our length. So based on the graph, if the length of the alligator was 130 centimeters, which of the following would be a reasonable belly width? So if the length was 130, so let's find 130 on our length. Okay, it's about right here. So if we drew a line through there, and then look and see where 130 falls. Somewhere in this range. So let's look at our answer choices. This range is about, oh gosh, somewhere between 25 to 30. So let's check our answer choices and see if any of these match. A says 10 centimeters. Well, that would be about right here. Does that fall in this line? No. B says about 20. Maybe. Kind of low, but maybe. C, 30. That sounds pretty darn good. We said between 20 and 30. That seems pretty good since it's going up. It's getting higher. So that's a big old fat maybe. D says 40. That'd be way up here, so no. So between 20 and 30, I would say just since it's rising and it's going up, that's more on the 30 side. 20 is a little too low. Number 9, the scatter plot below represents the number of sales and the amount of money earned. Our Y is our amount of money. Our X value is the number of sales. So based on the trend line, what would be the amount of money earned when 25 things are sold? So 25 things should fall about right here. So let's see if this trend were to continue, about where would this fall? Somewhere in here. So somewhere in the $500 range, okay? So let's look at our answer choices. A says about 200. Ooh, nope. B says about 400. Ooh, that's a little too low. I'll put a star. C says about 550. Well, that seems pretty good. I drew my line at about 500, so that's definitely the closest, and about 700. Holy cow, no. I'm gonna say it's C because that's as close. If you were gonna have a point there, really it would be above 500. 400 is just too low. Okay, number 10, the data in the table below represents a linear relationship. Like I've said before, you can find your M, you can find your B in the table. The B, that's gonna be your Y value when X is 0. What's your y-intercept? Okay, so when x is 0. So on this table, we got lucky, and I see x is 0. So look at your y value attached to that. That's my b. 6. So then I need to find my slope. And already, since I know b should be 6, I can look at these equations down here, and I can eliminate d, and I can eliminate b, because that's not correct. It should be positive 6. So now we need to find our change, our slope, our m. So find your, since it's such small numbers, guys, if it's like this, just do it by hand. Don't worry about doing it in the calculator. So change in y for my m, change in y for my change in x. So if I take 14 minus 10, my change here is 4. If I take 2 minus 1, 1. So my change in y was 4, my change in x was 1. So that's my m, or my slope. We can reduce it down to just 4. Look at these answer choices. A, it's the only one that matches. Line M has a slope of negative 4.25 and goes through the point 4, negative 11, x, y. Which equation best represents the line M? So if it has a slope of negative 4.25, slope is your M. Don't be confused by the line saying M, but slope is your M, negative 4.25. So already I need to look at these numbers and eliminate anything that doesn't say this. So goodbye B and goodbye D. So negative 4.25. So now you just have these two answer choices. And to me, for this problem, the easiest thing to do is plug these in. So take your negative 4.25 and plug in 4 for your x on both of them, for both of these equations, and see which one gives you negative 11 as your answer. So let's look at this first one, A. So negative 4.25 times 4 gives me negative 17 plus 20. So that gave me an answer of 3. Is that the same? No. So just to make sure, let's check this one. So negative 4.25, we'll do it again just to make sure, times 4. Negative 17 plus 6. Negative 11, negative 11. C. 12 scatter plot data shown below. So it looks like we're just trying to decide what kind of scatter plot's going on here. So we can see all the points are kind of generally going down. So that means we have a negative association or negative trend. So already, and we don't need to know if it's linear or not. So that's all we need to know. They're all kind of going down. Okay? So that's going to be a negative correlation. All the points are, as they go, they're going down generally. Number 13, the graph below shows the energy and fat content in a number of foods. Which of the conclusions is best supported by the data? So let's see, our Y value is our energy, our X value is our fat. So it looks like as the fat content gets higher, your energy in kilograms gets higher. Anyway, so it looks like your grams are getting higher as your energy is getting higher. So we could draw a straight line through it. So A says there's no association between fat content, I can't say that word, and energy. Well, is that true? No, it looks like there's a pretty solid relationship. It's positive too, since it's going up and to the right. B, there's a strong negative linear association between the fat content and the energy. Well, already I know that that's not true. It's not a negative. It's going up and to the right, so we know it's positive. C, there's a linear relationship between the fat content and energy, but the energy level remains the same regardless of the fat content. Well, was that true? Not really. Let's see what D says, just to make sure they're not trying to trick us. D, there's a strong positive correlation between energy and fat content. I'm going to say D. It's a pretty solid correlation. It's going up. Your energy is increasing as your fat's increasing. It doesn't plateau. It doesn't go straight anywhere.